Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. In this video, we're going to be discussing piecewise defined functions. I find many algebra students find these a bit difficult, not because they have trouble graphing, but because they don't understand the language and how it's written, nor the purpose. So we're going to start off today with a real-life example of something that might happen in your world. So let's say you're an hourly employee, and you're going to get $15 an hour for the first so many hours you work. Generally, that's anywhere from 0 hours to 40 hours. And then after 40 hours, they're going to give you what's called time and a half. Now you're going to get the time and a half for the full 40 hours. Instead, you're going to get that $600 for your first 40 hours, plus an increased pay of $22.50 an hour, but you're not going to get it for every hour. You're just going to get it for hours past 40. So if I go ahead and I simplify that, that would be 600 plus 2250H minus 900, combine like terms, and we got 2250H minus 300. So for example, let's say you work 41 hours. I can now put 41 in here. So that's going to give us 22.50 times 41, and then subtract that 300. And you'll notice it's $622.50. So with that 1 hour of overtime, you get that $600 plus that $22.50 just because you worked 1 hour of overtime. So that's why the simplified equation works once you hit hours past 40. So what is that going to look like in our algebra classroom? Well, instead of using H and having, something logical with the variable and giving you a real life example, you're going to see this. I'm going to use the same example. I'm just going to write it in the proper format for algebra. So we'll have 15x, and we'll have 22.5x minus 300. 0 is less than or equal to x is less than or equal to 40. X is greater than 40. So it's the same information. It's just written slightly differently, utilizing x instead of an h. Sometimes you might see a comma afterwards. Sometimes you might see a semicolon. It's just a way to differentiate between the equation and when to use the equation. So again, in our example, we're using the 15x for the hours between 0 and 40, and then after that, we're changing over to the other equation. So what's that going to look like graphically? When I make graphs for real-life examples, I make sure that I number according to something that makes sense. So my hours, instead of going all the way by 1s to 40, I'm going to use 10s. 10, 20, 30, 40, 50. And you'll notice I labeled my independent axis. And this is going to be our total pay. And it's going to be in dollars. And since pay climbs pretty quickly, I'm going to number by hundreds. 500. There's 1,000. Okay, so graphically, we're going to use this equation with a y-intercept of 0 and a slope of 15, which means go up 15 over 1, which is hard to see. So a slope of 15 over 1 is equal to 150 over 10. So there's 150 and then there's 10. So it does look different whenever you number your independent, dependent axes by different scale factors. The other thing you could do is go, okay, if I work 0 hours, I get $0. If I work 40 hours, I get $600. So we could put the 0, 0, and the 40, 600. And those are both closed dots because it's underlined. Once we hit this, we're going to switch over. Now, if I put 40 into this equation, I still get 600. And so that's not a underline, so that would be an open circle. They just happen to meet at the same place. Not all piecewise functions will meet in the same place. And since it doesn't end, I'm going to do another point so that I don't have to worry about the slope of 22.5. If I work 10 hours of overtime, which is 50 total hours, I will get that additional $225. So that's going to take me to $825. So that would be 50 hours. Here's 600, 700, 800, and I'm going to estimate my 25, and then we have that. So what we can see here is that we had the slope going on for a little while, and then it increased. And that's exactly what a piecewise function does, is it takes pieces of different equations and puts them together on one graph to simulate something going on. Let's go ahead and see what that would look like in an algebraic type form. So we have a function f of x equals, our first part is going to be negative 2x minus 4, with x is less than or equal to negative 2 as our domain, negative x squared plus 4, negative 2 is less than x is less than or equal to 2, x minus 4, x is greater than 2. And you'll see a big open brace to start us. That's just saying that all three of these are connected to make the single function f. We are going to overdo this to begin with, just to make sure everything is clear. So let's go ahead. We're going to graph on this coordinate plane. We shouldn't need to graph too much. Window of about -5 to 5 should be sufficient. I'm going to utilize 3 different colors so that we can see this very clearly. We're going to graph the first one in orange. So it is in slope-intercept form, y equals mx plus b. The number that's by itself is where we begin. So we're going to start -4 down. 1, 2, 3, 4. You might also remember our transformations, that any number at the end is its HK shift. So this one has been shifted down 4 spaces. It's linear because there's no exponent, and it's been stretched by 2 and reflected. Or you can remember in junior high, you did the down 2 over 1 for the slope. I'm going to reverse that back up so that we don't go out of our window, and connect those with a line. Again, no exponent means linear, right? Our next one that we've got is quadratic. It's been shifted up 4 and reflected, technically reflected and then up 4. So instead of a happy face, we're going to have that frowny face. We're going to move it up 4 spaces. And we're going to go ahead and graph that parabola just like it was in our transformations video. If you don't understand how to graph a parabola, that's not a big deal for the purpose of learning what's going on here. But I would go ahead and watch one of those videos to pick that up. And our last one is going to be x minus 4, so it is a linear equation, shifted down 4 spots. It has not been reflected. We're going to go ahead and create that line. So there are 3 functions here. However, when I put them together, right now they're not making a function. They're making some kind of weird, I don't know, shape. However, they told us to use a function and they limited our domain. So if you remember when we talked about domain and range, if you've watched that video, you would see that we have a wall at -2 and we're going to the left. So -2 would be right here, and they only want us to keep this graph to the left of that spot. So I'm going to highlight that part. Since that's colored in, that goes with that closed dot. They only want us to keep this part of the first equation. For the equation that I graphed in blue, we have a wall at -2, and we have a wall at +2. I put the dashed line because it's not underlined. I put the solid line because it is. So they want us to use between -2 and +2. They only want us to use this section of the graph. So that would be an open circle here. However, it matched up to the other circle. That's okay. And we come here and we have a closed circle. And then our last part, we've got this here that starts on the green. It has a wall at 2 and it wants us to go to the right. So we have a wall at 2. We want to go to the right. So it was not underlined, so that's an open circle. So what's highlighted is our answer. Everything that's not highlighted is superfluous. I know, big word. It's okay. Your English teachers will love you if you use bigger words. So I'm just going to copy what we have here. Let's see. Let's pick 1, 2, 3, 1, 2. So negative 3, 2. It was a solid dot at negative 2, 0. And it came in. Then we have the parabola. It had the open circle. We had our parabolic arch. And then at 2, negative 2. We had our third part. It is okay that we have a gap. Not always will the piecewise functions link up. It happens. It's not a big deal. So our domain, when we put all three parts together, the graph in orange used this part of the x-axis. The graph in blue used this part of the x-axis, and the graph in green used this part of the x-axis. So when we put them all together, there were no walls for our x part. So that means our domain is all reals. However, with our range, our ceiling on our floor, this is our low point right here. But it keeps going up, so we have no ceiling. We only have a floor. And our floor is at negative 2. And it keeps going up from there. There's no ceiling. Because this is an open circle, we're going to use a parenthesis. And we have y as an element from negative 2 to infinity. So we can do a domain and a range for a piecewise function, which is also known as a patchwork quilt. Now, if they actually had given us walls for everything, sometimes it does not go to infinity. We must read the problem. That's very important. For some people, the method that I just described is a little bit too much and they don't want to work that hard. For those, we're going to go ahead and give a slightly different effect. So if you didn't like the previous option, you might like this. Alrighty, sometimes you'll see a semicolon, sometimes you'll see a comma. Okay, they separate them differently occasionally. So we have three equations here that we're going to go ahead and make a patchwork quilt of. So if you do not like to choose to do it with the method where you draw all three graphs and then you come back and you just highlight the part you need to keep, we have another method for you. Okay, we know that this is a downhill line because it's negative. We know that this is an uphill line because it's positive slope. And we know that there's no variable x here, so we know this is a constant function. We also see that there's a left side and a right side, or walls, which means this particular graph starts at negative 2 comma something and ends at 1 comma something. Since it's underlined, we know that's going to be a solid dot. It's not underlined, that will be an open dot. We can now utilize a calculator to find that value. Substitution, negative 2 times negative 3 is 6. 6 plus 1 is 7. Negative 3 times 1 is negative 3, plus 1 is negative 2. So we will have a line connecting these two ordered pairs. Our next equation is going to start at 1 and end when x is 5. Again, that is a solid dot here and an open dot here. I know it matched to above. That just happens to be a coincidence. And let's go ahead and substitute. 1 plus 2 is 3. 5 plus 2 is 7. And then our third line, that constant of negative 2 is going to start at 5 comma something, and there's no end. It keeps going, right? X is always greater than 5. So no end. We will have an arrow. If I substitute 5 because it's a constant function, our y value is going to be -2. Constant functions mean your y value do not change. So let's put these points on the graph and connect them. Okay, remember our graph needs to go up to 7, so make sure you leave room. So sometimes if you think about it, 7, 6, 5, 4, 3, 2, 1, 0, that will help you get your axes so you don't have to redraw. Alrighty, so -2, 1, 2, 3, 4, 5, 6, 7, solid dot, 1, -2, open dot, connect, 1, 3, 5, 7, connect, and then 5, -2 is going to be continuous. That's at -1. There we go. Now you'll notice, this is very important with our domain and range, is that if we put this all together, one color, right? That's the entire point of this, is to make it all the blue graph. Where we stop at 1, we pick up again at 1, and we continue, and we get almost to 5. So then we come down here at almost 5, and we continue. Remember that dot's not supposed to be there. I couldn't count. That's our graph. So what is our domain? Where's our walls? So you'll notice I've gone ahead and redrawn our graph so that I took out that small dot mistake that wasn't supposed to be there. That way we could see our domain and range better. Again, it's really important to understand where each section starts and stops, and those are because of how the problem is written. So the first section had us going from -2 to 1, and then it stopped at 1. The second section had us going from 1 to 5, and it did not include 5. And then the final section did not include 5, but then it continued on. So by looking at those 3 highlights together, we can see our domain has walls that starts at -2 and it continues. We were going to skip it but because of the first domain, but then the second domain included it. So we continued in orange, which was that second domain, and then we get to this section and we skip 5 above, and we also skip 5 below. So 5 is completely excluded from our domain. So how are we going to indicate that? So first of all, we have our x as an element of. We had that wall at -2, and we continued to 5, but we did not include it. Then the next section of the graph skipped over and started at 5, and it continued to the right forever, but it also excluded 5. So you'll notice neither group included 5 in the walls. So maybe think of that like a gap in the road, you know. The bridge just hasn't been built yet, maybe. So they would have built that bridge, we had connected those 2 pieces, but they chose not to. Our range is a little bit simpler. So we can see here that we have a floor and we have a ceiling. And it appears, because of the 2 open circles here, that we should not include this floor. However, there's a closed circle right there. So we actually have to include this floor. Had this not been at this point, had it just been the open circle, and maybe this was up there one spot where I accidentally put it before, then we would have used the open circle. But this dot or this dot or this point or this point or this point, all these points are why we are actually going to include our floor. And because this is closed, it overrides the open, and we're going to include the ceiling. So our y's exist between -2 and +7. So we had a floor and a ceiling in this case. Again, when you're graphing, you can use your HK shifts. If it's a linear line, you can use slope-intercept form. But it's really important to know where each piece starts and ends so that you can get your final picture. Your picture again may not always connect. In this case, ours did not. And it jumped around. Sometimes they're just giving you weird ones just to make sure you understand what's going on. It's not necessarily a real life problem. However, we can utilize these in real life as we demonstrated with our first example.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.